This is part 2 of the wrist joint lecture. We're going to pick up from part E on the lecture notes entitled Muscles. Earlier I had mentioned that there are some commonalities. If we look at the extrinsic muscles, the wrist flexors in this case, the common origin, medial epicondyle. So how do I know I'm looking at the posterior or anterior surface? There's a couple giveaways. One, you see pisiform, tells me I'm looking at anterior. I can also see the radial tuberosity, again anterior view. So the common origin for the wrist flexors, medial epicondyle. Posterior view, I can see the olecranon process, olecranon fossa. Those are the two giveaways for myself as to what I'm looking at, what surface. And the common origin of the wrist extensors is the lateral epicondyle. Now let's start with the wrist flexors. Your textbook has some really good pictures on page 186. And here's the great thing about how these muscles are named. It really helps you figure out what they do, where they are. So flexor carpi ulnaris, flexor carpi radialis, flexor, so that automatically tells me medial epicondyle. Carpi has to insert on the carpals. Ulnaris tells me that it is going to attach on a carpal or carpals on the ulnar side of the hand. It tells me that this muscle does wrist flexion and ulnar deviation. If we look at flexor carpi radialis, flexor, medial epicondyle of the humerus, insertion point, carpal or carpals on the radial side of the hand, flexor, wrist flexion, radialis, radial deviation. We also have to look at palmaris longus. Well, longus tells us that it's a long muscle. Palmaris, palm of the hand. Flexor, common origin, medial epicondyle. That's our origin. Insertion, palmar. How about the palmar aponeurosis? So this is assistive in wrist flexion. Now, let's talk about how to remember the nerves, because in chapter 13 we're going to look at more of these flexors. I don't know what nerve. If I had to guess, I'm going to say median, because all but 2 of the flexors are innervated by the median nerve. So if you have to guess, say median nerve. Now all you have to do is memorize the 2 exceptions. All right, there's 2 exceptions. Otherwise, if somebody says, well, what's the nerve for the flexors? I don't know, median. Let's now take a look at the extensor group. So we're going to have extensor carpi radialis longus. Can't get both hands in the image of this. And then extensor carpi radialis brevis. So when you have a longus, you're probably going to have a brevis. So there's not a lot of length difference in these 2 muscles, but I can tell you that the extensor carpi radialis longus originates up on the supracondylar ridge, again posterior aspect, runs down to the hand, carpi, so it's going to insert on a carpal. You just have to figure out which one or which ones. Whereas the extensor carpi radialis brevis, lateral epicondyle is the origin. Again, follow the name down to and figure out which carpals it inserts on. And then we have extensor carpi ulnaris. Extensor carpi, we know it's going to follow the ulnar bone this time rather than the radius, and insert on one of these carpals. Figure out which one. So what's the nerve? Well, that's easy. Any muscle in the upper extremity that originates on the humerus, posterior aspect of the ulna, posterior aspect of the radius, if that's the origin, posterior aspect, the nerve is automatically radial. No exceptions. No exceptions. So let's look at these names again. Flexor carpi radialis longus. Wrist extension, radial deviation. Extensor carpi radialis brevis, only wrist extension. And it's look closely at the insertion point on the carpals and you can see why it really doesn't do a deviation towards the radial side. And then extensor carpi ulnaris, extension, radial deviation. Okay, let's talk a little bit more about nerve innervation. Human body has a lot of redundancies in the event of nerve injury or spinal cord injury even. So flexor carpi ulnaris, ulnar nerve. Flexor carpi radialis, median nerve. Now if we look at the extensor group, we're automatically going to say radial nerve. So that adds a third nerve. So what do I mean by that? Well, I'm really referring to deviation. So let's say that someone has an injury to the ulnar nerve. Do they completely lose ulnar deviation, or is ulnar deviation weakened? Take a minute to think about that. Pause the video if you have to. So if the ulnar nerve is injured, where it's no longer innervating flexor carpi ulnaris, it becomes a weakened motion, because remember we have extensor carpi ulnaris, which still allows ulnar deviation. It's just a weakened motion. Same thing with the radial side. If that median nerve is injured, so that it is no longer innervating the flexor carpi radialis, you still have extensor carpi radialis longus, allowing for a weakened radial deviation. And the same thing with the radial nerve. If it's no longer innervating the extensor muscles, you still have the flexor compartment that will allow a weakened range of motion, weakened strength for those deviators. So generally, when we are talking in the human body, is something lost or weakened due to nerve injury or deinnervation, or in some cases spinal cord injuries, most of the time the answer is going to be weakened, because there's a redundant nerve built in there for almost everything. There's a couple of exceptions, triceps being one because it's radial, There is no other elbow extensor, so active motion through triceps, if that loses innervation, it's gone. Doesn't mean you can't extend, but you'd have to use the flexors eccentrically. Another exception would be wrist extension, because again, those extensors are innervated by the radial nerve. The deviation becomes weakened because you have the flexor carpi ulnaris, flexor carpi radialis. Another exception would be dorsiflexion, but we will talk about that in a number of weeks. Okay, rewatch these videos, pause them. Again, come prepared to ask questions. Thanks. I hope you enjoy the videos.